let's explore a problem using the fundamental theorem of calculus. So for example, suppose that we have the following function, f of x equals the integral between x squared to 4 of the square root of 1 plus t squared divided by 3t squared dt. And suppose that we are interested in finding what is the value of the rate of change of this function at 1. So we could try to work out this antiderivative first, but that would be a little bit tricky. If you look at this expression, it's a rational function and a square root. That could be a little bit tricky. Later in the semester, we're going to learn how to work this out. But right now, maybe we can make use of the fundamental theorem of calculus. One way to realize that that's a good idea is because we are aiming for a derivative. In other words, every time that you see the derivative of an integral, you should think about the fundamental theorem of calculus. So the first step is to find the general expression for the derivative, and then we can plug x equals 1. In this case, if I want to find the derivative of this expression, simply it would be the derivative of the definition that we had in here. So remember, the general strategy using the fundamental theorem of calculus is to simply replace the function with the upper and lower limits and then to multiply by the derivative of each of these. So in this case, what we would have is that I just need to plug the function with the upper and the lower and then multiply by their derivatives. So I'm just going to use a pretty much straightforward rule that we have in here. That means I'm going to apply the integrand at 4. And then I would need to multiply by the derivative of 4. But the derivative of 4 is just 0. In other words, the very first term actually will go away. It will disappear. And this should remind you a little bit of what we said on Monday, that whenever we have a constant, that term is not going to be there. But for the lower limit, it will survive. And really what we need to do is to replace the t by the x squared in this case. So it should be x squared divided by 3 times x squared squared. Notice again that I'm replacing x squared by t. So that's why in the end we have these two squares over there. And then I have to multiply by the derivative of x squared. In other words, this is basically a chain rule. So let me just simplify this expression a little bit more. Again, notice that the first term completely disappears because we're multiplying by 0. So in the end, we will get the following. We will get minus the square root of 1 plus x to the 4th power divided by 3x to the 4th power, whole thing multiplied by 2x. And I think we can simplify this a little bit more. I'm just going to distribute that square root on top and the bottom. So on the top, it will be just 1 plus x squared. And on the bottom, it should be just the square root of 3 times x squared multiplied by 2x. So I can simplify this a little bit further. And this should give me 2 over square root of 3 times 1 plus the square root of 4. And then this guy cancels one of these. So I'll just get a single x on the bottom. So this is the expression for the general derivative or rate of change for this function. Now notice that we are interested in finding the rate of change at 1. So the only thing that I have to do is I have to plug x equals 1 into this expression. In other words, that would give me that the rate of change I'm looking for is going to be 2 divided by the square root of 3 times square root of 1 plus 1 to the 4th power divided by 1. And I guess I can manage this one. This would give me 2 times the square root of 2 divided by the square root of 3. And that will be my answer.